Okay, so this time you are asked to write scientific notation with 3 significant figures. Let's start with the first item. The first item is 555,500. Because you are asked to have it in 3 significant figures, underline first your first 3 significant digits, which are, in this case, the first 3 fives, correct? Because the instruction says you should only have it in 3 significant figures. So that means you're only focused on the first 3 fives. Then we encircle it. Same process. Encircle it. Here is another thing you need to be careful. The moment you are asked to express it at a certain SF, you need to be watchful if there is a need to round up. By looking at what you're dropping. The first number you're dropping is a 5, and we know the rules for rounding up. If it's 5 up, then that means the last significant digit has to be rounded up. So what's going to happen to our third 5 here? It's going to turn into 6. So this is what I do in order for me to be reminded of that. I put a slash there, and then I put a little 6 there. So when I write it down, I will be reminded that it is 6. Okay? So I rounded up to 6. Now I don't have a problem with my significant digits, which are 3. In this case, with the rounding off. The second step is we transfer the decimal point. The decimal point initially in a whole number is all the way to the end. We will transfer it to a position wherein we leave only one non-zero number before it. So that means I should be putting my decimal point after the first 5. Right? And after I identify the destination of my dot, I'm going to count now how many numbers I will skip. So that's going to be 1, 2, 3, 4, then 5. So I have moved 5 times. You write it below. I have moved 5 times. Should it be positive or negative? Positive, because it's a huge number. So I leave it as 5 there. Now, step 2 is done. We are ready to write our scientific notation with 3 significant figures. Let's write it down. So it's going to be 5.5 and 6, because we already rounded up, times 10 to the power of positive 5. And that's the answer to that particular item. Okay, let's proceed to numero 2, number 2. Number 2 is 0.00156,010. So that's a small number. What do we know if the number is very small? The exponent has to be what? Positive or negative? It should be negative. So just take note of that. First step, significant figures. We are required to express this into 3 significant figures. So what are our first 3 significant digits? We have 1, 5, and 6. Don't include the left zeros because they're just placeholders. They're not counted. So we encircle the 3 significant digits. Well, is there a need to round up? Is there a need to round up? What's the one you're dropping? It's a 0. Do we need to round up your 6? No need. So just as is. Now, we're going to move the decimal point. The last step, step 2. Our decimal point is initially here. Where do we transfer it?
Between the 1 and 5.
Between 1 and 5. After the 1. Then we count. 1, 2, 3, and 4. You move 4 times. And what did we say? Should it be negative 4 or positive 4? It should be negative 4. Now we are ready to write our scientific notation. What is the final answer in this case? 1.56 times 10 to the power of negative 4. And that's the final answer to number 2. Are you following? I hope you're following. I'm asking all of you?
You.
Okay. Yes, Tracy, yes. About this? About this?
Yeah, how do you
Uh-huh.
know when it's negative or positive?
You look at your given. 0.00 is less than 1. If the given is less than 1, automatically you should put a negative sign. If it's more than 1, then your exponent will be positive. That's it. Go back to your given. And that will just be the only question you're going to ask yourself. Is my given more than 1? If yes, positive exponent. Is my given less than 1? If yes, then negative exponent. You will be the one to do the analysis of your given. Okay? Let's go to the third number. Third number. So 101 500. So 101 500 expressed in scientific notation with 3 significant figures. First step, underline or encircle your 3 significant figures. What are these? 1, 0, and 1. 0 is significant because it's in between 1 and 1. If the 0 is in between non-zero digits, that is counted as significant. So 0 is included. Then encircle it. Wait a minute. We encircle the 3 significant figures. But we need to be careful of what we're dropping. We're dropping a 5. So what is the rule when we are dropping? Okay, so the 1 here will be rounded up to 2. So put a slash and put a 2 there. So that you will be reminded that that should be written as 2. That's step 1. Step 2 is we are going to move our decimal point. This is a big number with no decimal point. So it is assumed that the decimal point is all the way to the end. Where will we transfer our decimal point? It should be after your first non-zero digit, which is 1. So we put it here. And now we're going to count how many numbers we skip. 1, 2, 3, 4, 5. It's very important that you count carefully. If you're not comfortable with the curve because it's going to confuse you, just count the numbers here. So that's 1, 2, 3, 4, and 5. You still get the same number. And that is 5 here. What should be the sign of a 5? Positive or negative? Positive. Because the value is greater than 1. Now we're ready to write our scientific notation. So it's going to be written now as 1.02 because we rounded up times 10 to the power of positive 5. And that's the answer to number 3. Question. We're off to the last number. Hang in there, please. The more examples, the more it's going to get easy. Number 4. 0.000034550. That's a lot of numbers. But is this number greater than 1 or smaller than 1? Smaller than 1. So you should have a negative exponent. First step. Underline and encircle the 3 significant figures. What are the 3 significant figures in here? 3, 4, and 5. Let's encircle that. But then, what do we do with the first 5 that we're dropping?
You have to.
You have to?
Return the 5.
Okay, round up your third digit, which is the 5. What's going to happen to 5? It's going to become a 6. Write that down so you won't forget. After this step, we will now be moving our decimal point. Our starting point is here. Where do we transfer our decimal point?
Between the 3 and the 4.
Between 3 and 4, right there. So that's going to be the perfect spot. Then we count 1, 2, 3, 4, and then 5. So that's 5 times. Should it have a negative or positive sign? Negative sign. So put it there. Now we are ready to write our final scientific notation. So it's going to be 3.46 times 10 to the negative 5. And that is the final answer to number 4. I hope that with this many examples, you are able to master the writing of scientific notation.